Okay, so we're talking about synthetic division today, which is where you have a polynomial or a multi-term expression divided by a binomial, which is two terms. So the way we do this is we make sure that all of these terms have coefficients. So if they don't have one, we want to draw in an invisible one. That might be a little tricky to see, so let me just rewrite it. And we also want to make sure we have one of each term in descending power order. So since this is to the third, we'll go ahead and bring that to the third power down. This is to the second, so we'll bring that down. This is to the first power of n, that's the linear term, we'll bring that down. And then we have plus 3. So we want to make sure that, like, if any of these exponents are missing, we would have to add in that term with a 0 in front, which we'll do an example like that too. So we're going to focus on just the coefficients that are in the front of the terms. We'll draw a little division bracket here, and we'll put the coefficients only and the constant in the box. We'll go ahead and we'll look at what we're dividing by. Circle that number. We're going to take the opposite of it, which an opposite of a -2 is a +2. So our first step is to drag and drop our first coefficient down, say 1. And then we are going to be multiplying by this outside number. So we have 2 times 1, which is 2. And then we always want to combine our like terms here. So we have a 2 and a 2. So that is a 4. And then we're going to stick with this game of kind of multiplying and combining. So we have 2 times 4 over here, which is 8, -11, and a +8 is a -3 when we add in our calculator. 2 times -3 is -6. And then we'll combine like terms there to get a -3. So this is our final answer, but we have to label it with our variables. So since we know the first term is at n3 and it's being divided by an n1, that means our very first term here is going to be an n squared because we subtract our exponents. So we're going to put an n2 right here. Then we just kind of go down from there. So the next highest power of n would be n1 or just n. You can put a little positive sign there since there's no negative. And this -3 becomes our constant. So this last little number over here, that's our remainder. So we can just put a little R button right there, or an R symbol to symbolize remainder. And this right here would be our final answer. So for polynomial long division, there is pretty much they're all the same, but sometimes you'll have a missing term, which can happen. We're going to do one with a missing term just so you know how to do that. And it doesn't look like any on this note sheet have that. So we'll go ahead and do one more on this note sheet, and then we can do one with a missing term, and you can just let me know kind of what questions you have. And just a reminder to draw in those invisible ones. So if we're looking at number 3, we have 2 invisible ones. We can go right to our division bracket as long as we recognize that we're only focusing on the coefficients. So those are the numbers that are in front of the variables. So we have 1, 1, -50, and -62. We take the opposite of our 7 and we put it right here. Then we start with our drag and drop. So drag our 1 down, and then we'll multiply these 2 together. So -7 times 1, -7. So after you multiply, you're always adding, or if you want to think of subtraction, that's fine. But 1 plus -7 or 1 minus 7 is -6. So we'll do a -7 times a -6 is a +42. We'll go ahead and combine those. It gets us a -8, sign of the bigger number. -7 times -8 is 56. And negative 62 plus 56 is negative 6. So we look at our first term divided by our first term. So we have an A3 divided by A1, which is A squared again, just like the last one. So we have an A squared, and then we count our way down. So what is the next highest power of A? That's A1 or just A. This will be our constant, and this over here will be our remainder, which you can just put in R. And that's how you would write your final answer. There's also a few other ways to divide. The reason we do synthetic division in this class is because polynomial division is kind of complicated. But I do want to show you what you have to do if there's a missing term, and then we will call it good. So here we're going to draw our little bracket, and we're going to put our coefficient of 1 first. But you might notice that there's a 0x missing from this expression. So this is on the practice sheet. I didn't put any like this on the note sheet. So anytime that you have like a countdown of your exponents, but you have something missing, you want to put in a 0 for that coefficient. So then we have our negative 5 at the end. We take our opposite of this number, so that's 2, and we start with our drag and drop. So we'll drop our 1 down. 2 times 1 is 2. Those actually cancel, so we can put a 0 down there. So we have something to multiply by. 2 times 0 is 0. And 0 and 0 get me 0 when I add. So we're getting a lot of zeros here. 2 times 0 again is 0. And negative 5 plus 0 is negative 5. You can also work your way backwards. So I know last time we talked about how like x3 over x is x2. So we know this guy is x2. You can also work your way backwards from the remainder. So this is always your remainder of R. If it's 0, that would just mean there's no remainder. And this guy's always your constant. So there's no variable. This guy's always X, and then so on and so forth. So in this particular example, I'm kind of wondering how that happened. So maybe I made a mistake. Let me look. 1, negative 2, we added in the 0 and the negative 5. Put the opposite of 2, we drag that down. 2 times 1 is 2. Interesting. So for this particular example, we could check it by multiplying. So we have x squared, we have x, and we have 0. So I believe for this one, we're actually not missing anything. I just had a moment. But as long as we have every power accounted for, we're good. I just forgot that that one has an invisible 1. So you'll always have your variables counting down, your constant at the end, and your remainder at the very end. It's your choice if you want to work your way backwards, starting with labeling the remainder, or if you want to do this little trick of subtracting the exponents and then backwards counting from 2 to 1 to no variable at all. If you have questions about how to do synthetic division, or you want to choose a different method, please feel free to look into polynomial long division, but this way is just a tad easier. Hope this video helps, and let me know if you have questions.